Bismillah ar-Rahman ar-Rahim. Let's look at this problem 2 of the trial exam. We have a truss and we need to determine the forces, and every member of members HG, HC and BC. So we need to find the forces in the following members: HG, HC and BC of the truss shown, and that state the member of the members are in tension or compression. Assume all members are pin connected. Okay. The best cut is to do it like this. Again, you could do it by joint method, and that might take time. But the best method to do this example is by the section, by the cut. And this is the cut that I will be dealing with, cut A. But before we start the procedure, we have to look either right of the cut, and we can see that there is a ruler, so it's EY, and there is two loads, point loads, and we look to the left. We will have a pin, AY, AX, and also we have another load, 6 kilonewton. To me, I should look from the left, from here, because you have less forces to analyze. But before we do the section, we have to find out the reaction AX, AY. Eventually, the best is to go and find moment at E. Summation of moment at E equal to 0. Why we are doing this? Because we are trying to find AY. 3 kilonewton, it is positive. Again, you can see it, 12 meters is the total length. There is 4 spaces, 1, 2, 3, 4, and 3 meters each. I guess you took this in AutoCAD, and you should know how to read the following dimensions. So it's 3 meters each. So 3 times 3. And then this force is also positive, 9. Of course, 9 times 3 plus 3 is 6. And this force, 6 is still positive, 6 times 9. And the AY, you can see that the AY is negative minus AY times the total distance, which is 12 meters. And AX, of course, there is no moment for the AX because it is in the line of the action. So 3 times 3, 9 times 6, 6 times 9, AY. Okay. So you put this in your calculator, you find out AY is 9.75 kilonewton. Since it's positive, so it is the direction that I assumed is correct. In the exam, you have to put the magnitude, you have to put the unit, and you have to put the direction. Even though if you assume the direction of the negative or the positive moment. What's next? We need to find AX. So if you do summation of forces at X equal to 0, that's going to give you only AX. There's nothing else in the X-axis. That's for the whole truss. Again, that is for the whole truss. Okay, we have AX, we have AY. Now we do the cut. Now we proceed with the cut. So this is A, and this is H, and this is B. We have 6 kilonewton, and this is A. We have AY. 9.75 kilonewton, and it is going 9.7 kilonewton going up, and that's A, B, and H. Okay, so once we do the cut, the BC will look like this. This is the member force BC, and you do it like that, and this is point G, so this is the force H in the member HG, and this is H the member force HC. HG, HC, and BC. Now we are done. This is point C. Again, we don't have to include this force because we did the cut before that force. So this force is not included, and this, of course, the reaction AY is not included. We just do the cut, and we should look to the left, and these are the forces that we should have. 6 kilonewton and 9.75 kilonewton. Let me erase so I could look at the slopes. Okay, so let's look at the member HC. So if you look, this is 3, and this is also 3. So this would give you 3, 3, and what is the diagonal? 9 and 9, square root of 18. Okay, and let's look at HG. HG, if you look at like this, this is 3. And what is, you could see it here, this is 3, and this is, the whole thing is 4.5. So 4.5 minus 3, this one is 1.5. So this one is 1.5 meters. Okay, so you do the diagonal, and that will be 1.5 square plus 9 under the square root. This would give you 3.35. So now let's start the analysis. The first equation to proceed with this type of analysis is you take this moment. You take moment at point H. Summation of moment at point H equal to 0. And of course, you're going to assume that this is negative. This, you will not include HG, you will not include HC, because they are at the line of the action of the point H. And then you could see here, BC will do a positive moment times this distance. This perpendicular distance is 3. This load is not included because it is at the line of the action of the point H. And then 9.75, it is negative. And it's point H, so it's 3 meters from here. This is the perpendicular distance of 9.75 kilonewton from point H. So times 3. There's no other forces equal to 0. It's very clear that BC is 9.75. So the force in member BC is 9.75 kilonewton. And since it is plus, so it is tension. Okay, what other equation I should use? This is the first one. Again, it's really good to find the summation of moment at point C. So if you take moment at point C, you will not include BC and you will not include HC. and you could find Hg. So summation of moment at C equal to 0, and that is negative. And now you could include, this time you could include 6 kilonewton. 6 times 3, and this one 9.75, it is negative, times 6, okay, 9.75 times 6. And now Hg. For the Hg, we have two forces. We have one force in the x, and we have one force in the y. Let's do the first force in the x. The force in the x is going to be a negative, Hg. And since it's at the x, so it will be 3 over 1.5. Let's close this. 3 over 3.35. Okay, times the distance, which is 3 meters, and that is the perpendicular distance from this horizontal projection of Hg from point C. How about the Hgy, this one? The Hgy also will do a negative moment. 1.5 over 3.35 times the distance, which is also 3. So this is from here to here is also 3 times 3 equal to 0. I guess this, let me just look at it, minus 9.75 times 6 times 3, Hg 3 over 3 times 3. Okay, and now you will put this into your calculator. You'll find Hg, well, here it will be minus 10 kilonewton. So the answer would be 10 kilonewton compression. Okay, now what is the last one? Is to find Hc. Now, do you want to do another summation of moment? You could, but the best is to do summation of forces at y. Summation of forces at y, much easier, equal to 0. So we have 9.75, let's just put all the point loads, minus 6. There is, you don't include BC because BC is in the x-axis. You will include HC, so it is minus in the y-axis 3 over square root of 18. And also the Hg is plus Hg (1.5) okay, Hg equal to 0. And now Hg, since I assumed the tension, you're going to put this here minus 10. Don't forget, don't put the plus 10, because I'm assuming Hg in the sectioned truss, and I assume the tension, so I'm going to put here minus 10. So 9.75 minus 6. Okay, good. So you will use the calculator to find out Hc, the force in member Hc, and that would give you minus 1.03 kilonewton. and this is 1.03 kilonewton compression. I think we are done. We found the three forces, the three member forces of this truss. Thank you.